We're going to be looking at combining functions. We often start off at y is equal to f of x, and we transform things to be something. So lesson 1.1 was really taking a function y is equal to f of x, and we shift it vertically and horizontally so that it may become y is equal to f of x minus h plus k. Lesson 2 was really taking y is equal to f of x and transforming it so it might be y is equal to a f bx. Now in lesson 3, what we're going to do is we are going to be combining things. So in the first lesson, it was all about horizontal and vertical shifting. In the second lesson, it was about vertically stretching, vertically reflecting about the x-axis, horizontally stretching, and horizontally reflecting about the y-axis. And that was the second lesson. You know what today's going to bring, is going to be about combining the transformations. So really, we're going to start off with some general function, y is equal to f of x, and we are going to transform it so it might look like y is equal to a f b x minus h plus k, where a still represents the vertical stretch, reflection about the x-axis, b still represents the reflection about the y-axis and the vertical or the horizontal stretch, h is a horizontal shift, k is a horizontal shift. Now, think about what mathematical operations were done here. Well, we start off with point x, y, and for the shifts, h and k, we added to the x and y coordinates. Added. For anything that had to do with a reflection, what did we do? Well, really, we multiplied the y values. So anything to do with A and B, we did multiply. We could definitely interpret it that way. Anything to do with H and K, we added it to point notation. So let's get started. We can summarize all of these transformations in the general transformation model. Y is equal to a f, open brackets, b, close brackets, x minus h, close brackets, plus k, where the reflections in shrink stretch are captured by the parameters a and b. So right about now, I'm just going to say I would maybe call these the multiplicative. And the shifts capture the parameters h and k. I'm going to call these the additive. Does it matter in which order these transformations are applied? Definitely yes. Well, what's the correct way? Well, me personally, I like to look at it in terms of order of operations that we have to multiply before we add or subtract. So we tend to do the multiplicatives or the stretch and reflections first, and then we do the shifting. So since reflection and stretches are multiplicative, these transformations are done first. Since shifts and translations are additive, these transformations are done next. So here's a really great representation of what we do. And truth be known, I've never looked at this. It's overly complicated, and I find a flow diagram is a little bit confusing in this order. But this is not the only way that we can do transformations. Maybe we can go A, B, H, and K. Now, if you do it in that order, it's actually the order in which they appear in the formula. Multiply, add. That's certainly useful and an easy way to remember it. But you do have to know why we're doing it in that way. I'm just going to say you can also, there's other ways that you can do it. That is, the horizontal and the vertical are independent of each other. So you could do all the vertical transformations first and then do all the horizontal transformations. That is also an option.